Hi, my name is Thaddeus Williams, and this is my presentation. Now, people throughout this region of the United States love to fish. They fish for a living, they fish for fun, and many of them fish for fish. But besides the individual hobby, there's a huge fishing industry throughout the southeastern United States. And, as many people know, huge industries often come with huge problems. This moves us on to our topic, the outboard motor. Many people would consider this to be completely perfected, and while it is time tested, that doesn't take away from the fact that it can be improved upon. One such improvement is corrosion resistance, and another improvement is durability. We can't dive into a solution yet until we talk about how galvanic corrosion affects outboard motors like these. This type of corrosion occurs when two different metals come into contact with each other via an electrolyte. The less noble metal acts as the anode and is corroded, while the more noble metal acts as the cathode and is protected. This applies in this situation given the solution that's in place at the moment. Boat companies use pieces of metal to corrode in place of the outboard motor. These pieces of metal are called sacrificial anodes, and as the name implies, it acts as the anode. Typical sacrificial anodes include magnesium and zinc. And as you can see from the table, these are very high up on the galvanic series, which makes them extremely likely to corrode first when in contact with any of these other metals through an electrolyte. Now, typical outboards are usually made of aluminum, and when you look at this on the galvanic series, it stands pretty well. But many people still suffer with corrosion and durability issues. So, how do we improve upon durability without sacrificing the corrosive integrity that aluminum provides? In this case, we can make use of a steel alloy. Steel provides a much higher durability than aluminum. It also has a higher shear strength and compressive strength. But we still face this problem. It's lower on the galvanic series than aluminum. However, we can solve this by making it an alloy. This will make the steel cheaper, potentially stronger, and a lot more corrosion resistant, more than making up for the fact that it's lower on the galvanic series than aluminum. With that being said, we should get into the processing. A typical process for making this sort of steel is as follows. First, the steel would be annealed at 800 degrees for 30 to 60 minutes. This process softens the steel and ensures that it's heated all the way through, making it viable for further treatment. Next, the steel is austenized at 1040 to 1100 degrees Celsius. This transforms the steel into an austenitic structure and dissolves any carbides. It remains here for 10 to 30 minutes before being quenched, ending at martensite, which is a hard and brittle stage. Further strengthening is done by tempering it at 550 degrees Celsius for 1 to 2 hours. This steel ideally has a composition of about 0.1% carbon and 10% chromium to really bolster that corrosion resistance against the salt water, effectively making up for that which we have lost by moving down the galvanic series. And with that, our ideal steel alloy has been formed. Now that we have created this ideal alloy, we can look at how it compares to the aluminum. We already know that it has a good galvanic relationship with zinc and magnesium. And we also know that the deficit that's made between it and aluminum is made up for in the fact that it's an alloy, and by the fact that steel is 2.5 times more dense than aluminum, meaning that it will corrode more slowly. You can also see that from this chart, various steel alloys, including this one, are far stronger than aluminum could ever be. This is extremely important when considering durability, and when looking at all of these problems that these people have had with durability. One of the last things to look at here is weight. How does the weight of aluminum compare to the weight of steel? This goes back to the aforementioned density, which is one of the reasons that steel is heavier than aluminum. Even so, many would agree that this increase in weight is completely worth the higher durability. Plus, the density again provides more corrosion resistance. When considering these factors, the corrosion resistance and the strength, switching to a steel alloy like this one is not only not a problem, but an extremely viable solution to degradation and corrosion. In conclusion, many people would agree that the increase in strength and similar corrosion resistance is completely worth the increase in cost to replace aluminum with a steel alloy. Thank you.